Hi everyone, I'm back again. I'm here to do LeetCode problem number 3, longest substring without repeating characters. Let's read the problem. Given a string S, find the length of the longest substring without repeating characters. So essentially, a substring of a string is any string that's you're given a string S of a certain length, so this string has 1, 2, 3, 4, 5, 6, 7, 8 characters. Any string that has less than 8 characters that's a subset of the string S, that's considered a substring, right? And you want to find the longest substring without repeating characters. The answer to this example is 3 because you have A, B, C, and then the fourth character here is an A, so that's a substring with repeating characters, and so same with BCA, and then B again, and as you can see, that's also a substring with repeating characters. So if you calculate all the substrings without repeating characters, the answer is 3. You have this string right here, B, 5 B's in a row. That has an output of 1 because the longest substring without repeating characters is just B. And you have PWWKEW. The answer is WKE, which has a length of 3. Notice that the answer must be a substring. So PWKE is a sequence and not a substring. Okay, yeah, it definitely has to be a substring, right? So this problem can be a little bit tricky. It's a medium, but we can definitely do it. Let's try. So I always like to write down the constraints. The reason why I like to write down the constraints is because it sharpens your approach to solving the problem. You know right away what you're dealing with regard to the inputs to the problem. Okay, so we know that the length of the string that we're given could range from as low as 0 all the way up to 5 times 10 to the 4th. So a brute force approach is just not going to work. So it has to be, you have to do things a bit smarter than the brute force approach. The brute force approach being that you start with the first character and then you calculate all the substrings that are associated with the first character, then move on to the second character and calculate all the substrings that start with the second character and are associated with the second character, so on and so forth. That's just not going to work. It also says that S consists of English letters, digits, symbols, and spaces. Okay, that works for us. S consists of English letters, digits, symbols, and spaces. Okay, that works for us. So the topic, I believe, is a 2 pointers. 2 pointers, and the type of 2 pointers problem is the tortoise and hare. The tortoise and the hare approach. I believe that's just how you spell it, right? Tortoise, the hare and the tortoise. Okay, I spelled it right. It's a 2 pointers problem that's of the tortoise and hare variety, where you have one fast pointer, which is a hare, and one slow pointer, which is a tortoise. But let's check what they say. Okay, this is a hash table, which is true. We need a hash table, string, or sliding window. Or sliding window problem. Yep, the tortoise and the hare approach really is kind of like a sliding window. The sliding window will not always be of the same width. Sometimes the window is smaller, sometimes the window is larger, but the tortoise and the hare approach is a type of sliding window. So let's design the approach. define an answer variable, left and right pointers, and a dictionary to hold the current substring. Loop while the right pointer is less than the length of string s. If the character encountered is not in the dictionary, if it's not in the dictionary, then there's a couple of things you need to do. You need to add the current dictionary, add the current character to the dictionary. Calculate the max substring without repeating characters, and update it update the value if we've found a new max, and then else what you do is you pop the value. This means that we found a duplicate. We found like a duplicate. This is when we found like a unique character that can be part of the substring without repeating characters. Else we found a repeat character, so pop the value from the dictionary using the left pointer. Increase the left pointer. Return the answer. I think this works. This works. So let's take a look at what we have. Right? Let's do it. I can do n equals len s. Answer equals, I'll define the answer later. Actually, I'm going to define L, R equals 0. They both get set to 0. And answer equals 0. And we also have to have a dictionary equals D. While R is less than N. If, let me do this, C equals S of R. If C is not in D dot keys, then you have to follow this 3-step process. C equals 1. You add it. So we're following this stuff right here. D of C equals 1. Then we calculate the max. Answer equals max. Answer len D, right? And then we have to I forgot something right here. Let me include it in the instructions. Increase the right pointer. R plus equal 1. Else C equals S of L. D dot pop C L plus equal 1, and then you return the answer. See if this works. Okay. Okay, boom. That works. Let me try one more time. Okay. Well, let me write this down. Okay, so the time complexity is O of n, because you have 2 pointers that each go through the string S one time. The string S, they each go through it one time. The space complexity is O of the minimum of n, comma m, where n is the length of the string S, and m is the number of unique characters in string S, right? The reason is that the space complexity, the dictionary could either hold if the string is all just unique characters, right? If it's all just unique characters, then the dictionary will hold every single character. The dictionary that we define right here will hold every single character, and so it's O of n space complexity. But if they're repeating values, right? If they're repeating values, then the space complexity is going to be m, where m is the number of unique characters in string S, right? Each unique character will go into the dictionary once, at least once, and then but then if it encounters a new unique character of the same type, the former one will be popped off. So that's why it's m is the number of unique characters in string S, and it's the space complexity is O of the minimum of n times n. Not n times n, O of the minimum of n comma m. Okay, so that's the problem that I just did. This is number 3, and so I thank you all for watching.